Here we are at our example 3A from our 2.6 set of notes. We're asked, here is the table showing the years of experience that each technician has served for a company and their corresponding hourly rate of pay. Now typically, not always, but typically the more experience that you have and more faithfulness that you have staying with a company, they generally pay you a little bit more for kind of staying with them and you know, obviously having more experience. So the goal here is then to write an equation that best fits this data. Now, anytime we're given some data, we can first immediately go ahead and plot that data. So this is our x-axis, here's our y-axis, and this x-axis represents the experience in years that might directly impact then that person's corresponding pay. So this would be our y-axis. Now, I'm going to go ahead and go by ones, and unfortunately, it may run off the graph a little bit, but that's okay, because I think that it's going to better illustrate what this overall looks like, this line of best fit that we're hoping for. So for the first item, we have 9, 17. So 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 17 goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. And then 16, 17 would be right about here. Then we end up with 4, 10. So 4 is right about there. Then we have 3, 10, which is right here. Then we have 1, 7. So 1, and then 3 below that. So that should be about there. And then we also end up with 10, 19. So this was 4, 5, 6, 7, 8, 9, 10. And so at 10, we end up with 19. So that's going to be 2 more above this one. So 18, 19. Then we also have 6, 12. So 6, and then 12 would be located, here's 10, so we're looking at about right there. Then we have 12, 20, so here's 10, 11, 12, and then 20 is just above that, so right around there. And then lastly, 8, 15. So 8, 15 is at the top of our graph. So we see some data a lot like that. Now, when we're trying to figure out what is our line of best fit, I'm looking at the data, and what we want to do is choose 2 points where we have the same number of points above the line as we do below it. So for example, if I was to compare this point and this point and draw a line between those 2 points, more or less a line, we would see that we have 1, 2, 3 points above that red line that we just drew, as well as 3 points below that red line that we just chose. So again, that's really what we want to try and aim for, 2 points, such then that we have the rough same number of points above it as we do below it. So the points that we chose here were 4, 10, and it looked like it was this one 17, so 9, 17. Again, I didn't just pick these 2 just because they're the first 2 in the XY coordinate table. I just picked the 2 that I felt were going to make the sense where we have the same number of points above that line as below it. Anytime we have 2 points, so we have 9, 17 and 4, 10, we're going to go ahead and find the slope of those 2 points. So here's our x1, y1, and here's our x2, y2. So then it looks like we end up with our m is y2 minus y1 over our x2 minus x1. So it looks like our y2 here is 10, minus our y1 is 17 all over our x2, here it is 4, minus our x1 being 9. 10 minus 17 gives us negative 7. 4 minus 9 gives us negative 5. So it looks like our slope here is positive 7/5 because a negative divided by negative is always a positive. So our m here is 7/5. Next, we're going to go ahead and use our point slope. And our point slope formula is y minus y1 equals our m times x minus x1. We'll go ahead and choose a point. We'll go with this one right here, this 410. And so again, we're just pretty much throwing those values inside of our point slope formula. We can use either point though, because again, it should work for this red line that we're trying to make. So either point is on that red line, and we can use either one. The first y is going to stay y just as he is, minus our y1. We're going to go ahead and throw in our y value for this. So we have 10 equals our m, here he is, 7/5. That we just found, times our first x stays arbitrary x, minus our x from our coordinate, which is 4. Going ahead and distributing, the left side is still going to stay exactly the same, equals 7/5 times x gives us 7/5 x. 7/5 times negative 4 gives us negative 28/5. And then lastly, to get y by himself, we're just going to go ahead and add 10 to both sides. So on the left side they cancel out, leaving us with just y equals 7/5 x minus this 28 over 5 plus 10. Now we're trying to combine these two ones, and unfortunately the only way that we can combine them is if we make this guy a proper fraction, or if we make this 10 an improper fraction and then add the two. I'm going to go ahead and change this 10 into an improper fraction, and what we would do there is really we have 10 is 10 over 1. In order to add these two numbers together, we have to get the same exact bottoms. So we would multiply the bottom by 5 to get this to be the same bottom of 5. And what we do to the bottom, we also do to the top. So 10, again, is really the same thing as saying 50 over 5. So we just change the way that this one is going to be looking is all, so that we can add it to this negative 28 over 5. So when we have negative 28 over 5, and we're adding 50 over 5, now we can go ahead and combine them since they have the same bottoms. So negative 28 plus 50 comes out to be positive 22 over 5. So then it looks like our line of best fit comes out to be y equals 7/5 x plus our 22 over 5. So again, here is our line of best fit. Again, somebody else's line of best fit might look slightly different depending if they chose some different points. But again, you want to try and get the same number above that line as below it. If it's one off, so in other words, if we have 3 on top and 2 on the bottom, that's okay. That's fine. But if we had, like, for example, 4 on top above that line and like 1 and below it, then you're probably going to want to choose a different point. Again, though, that is example 3 from our 2.6 set of notes.